Hi everyone, welcome back to IndusphereTech. In today's video, we will build a real-time urban traffic light simulation where an Allen Bradley Micro 850 PLC controls the traffic lights and vehicle movement inside NVIDIA Isaac Sim. We'll start by preparing the 3D assets in Blender, then program the PLC, connect Isaac Sim to the controller through Ethernet IP, and finally demonstrate a complete real-time digital twin running in closed loop. One of the core concepts behind Object-Oriented Industrial Digital Twin, OOIDT, is reusability. Instead of creating every object from scratch, we are going to reuse assets we've already developed for previous projects. This saves time while keeping a consistent visual style across our simulation. Before exporting your scene, make sure your camera provides a good overall view. Having the correct orientation in Blender will make positioning much easier once the scene is imported into Isaac Sim. Also, verify object names and organize the scenes properly. It becomes much easier later when referencing objects inside OmniGraph. To export the scenes, I'm using the custom Blender build provided for NVIDIA Isaac Sim. This allows us to export directly the USD while providing the hierarchy and object names. The graphic light logic is implemented as a simple sequential chart. Direction 1 receives the green light first, then the yellow phase. After that, both directions remain red for 1 second before switching to direction 2. The same sequence repeats continuously. Once the sequence is defined, implementing it in ladder logic becomes straightforward. Each step activates the corresponding outputs for the graphic light and also controls the vehicle permissions. Since this is not a PLC programming tutorial, I'll keep this section concise. If you've been following the channel, you have already seen this custom PLC reader node. It communicates directly with the Micro 850 using Ethernet IP and continuously exchanges data with Isaac Sim. One important consideration is synchronization. Isaac Sim and the PLC execute independently, so Communication must be fast enough to keep both systems synchronized. The PLC always remains the deterministic controller, while Isaac Sim only visualizes the process. The communication itself is based on lightweight Python implementation. The node reads the PLC tags and makes them available to the action graph without adding unnecessary latency. We don't need to divide into every line of the code since we have already covered this in previous videos. To simplify the graph, I created a dedicated script node that updates the graphic light materials. It receives 6 Boolean values: red 1, yellow 1, green 1, red 2, yellow 2, green 2, and automatically updates the visual state of each lamp. A second script node controls vehicle movement. Instead of embedding complex logic inside the action graph, all movement decisions are handled inside Python. This keeps the graph clean and much easier to maintain. Now, let's watch everything running together. The PLC executes the graphic light sequence. Ethernet IP transfers the output states. Isaac Sim updates the graphic lights. The vehicles respond accordingly. Everything happens in real time. This example demonstrates how industrial PLC can directly control a realistic graphic simulation inside NVIDIA Isaac Sim. Although this project focuses on urban traffic, the exact same architecture can be applied to manufacturing systems, warehouses, airports, automated guide vehicles, and many other industrial digital twin applications. That's one of the major advantages of combining a real PLC hardware with NVIDIA Isaac Sim. If you enjoyed this project, don't forget to like the video and subscribe to the channel. Let me know in the comments what industrial process you'd like to see connected to a real PLC next. Thanks for watching, and I'll see you in the next IndusphereTech video.